are now going to start our last but not least lecture on bioenergy. And the same way as yesterday, where we had the Professor Cortez talk about biofuels in Brazil, now we have another professor from Brazil, and I have the pleasure to introduce you Professor José Luis Silveira from UNESP, the University of the State of São Paulo, also a very old friend, let's not say how long, he is the coordinator of the PhD program on bioenergy at UNESP. UNESP is our sister. We are 3 sister universities in the state of São Paulo, USP, Unicamp, and UNESP. And so I have the pleasure to give the floor to Professor Silveira. Thank you very much, Professor, for coming here. And please, you have the floor.
Students, ladies and gentlemen, it's my pleasure to be here. Thanks a lot for the invitation of Sony and Professor José Roberto. I am not a coordinator of post-graduation program at São Paulo University, University of São Paulo, São Paulo State University, and the Campinas State University. I am vice coordinator of the Institute of Bioenergy at UNESP, okay? Not post-graduation. I am a supervisor in program, bioenergy program, okay? Also, I am a vice coordinator of this Institute of Bioenergy Research, and we have 2 laboratories in the College of Engineering of Guaratinguetá, okay? I want to try to show some pictures, some projects, and some studies about the hydrogen production using biogas from landfill and bioelectricity production using biogas of landfill and the use of biofuel in microgas turbines. Okay, we have studied about the syngas by the gasification and also the biogas of landfill in these devices. There is a thermodynamic study, and I will be trying to show all the pictures, okay? I have a short time, and the title of my lecture is about the some applications in bioenergy, renewable energy. I'm full professor. There are informations about my group in this site, Institute of Bioenergy Research at São Paulo State University. Em português, Instituto de Pesquisa em Bioenergia. Okay? UNESP has 80 laboratories of Bioenergy Institute. The central laboratory is located in Rio Claro City, and the 7 others in Guaratinguetá, Ilha Solteira, Botucatu, Assis, another São José do Rio Preto, 2 laboratories in Botucatu City, okay? It's a biography about my topics. I am a full professor and the executive vice coordinator, as I told, coordinator of Institute of Bioenergy Laboratory of Guaratinguetá, and the head of the Laboratory of Optimization of Energy Systems. My experience is about the thermodynamic in energy, heat transfer, and my actuation is about the renewable energy, bioenergy, cogeneration, thermoeconomic analysis, In this case, we have work about the exergo economic analysis using exergy, and it's very important in the conception of in design of the power plants and the energetic and bioenergy systems. We have work about the fuel cell, as for example, solid oxide fuel cell operating with biofuel. Technical, economic, and environmental studies of power systems. The main line of resources, biofuel production processes, gasification to syngas production, biogas, and biohydrogen production. Biomass gasification technologies, technical, economic, and environmental analysis of hybrid systems, considering renewable energy systems and bioenergy. It's very important. In this moment, we have a project, my group has a project in laboratory, the construction of hybrid systems in my laboratory using solar energy, wind energy, vertical turbines, storage of hydrogen, electrolysis to production of hydrogen, and also using the hydrogen in fuel cell. Technical, economic, and environmental analysis of biofuel production. There are many applications to pulp and paper industry and the sugarcane industry. For example, in the case of gasification of the sugarcane bagasse in sugarcane, we can produce 2-3 times of electricity in the factory. Okay, it's very important to planning of energy to Brazil. Use of biofuel in heat recovery, steam generator, internal combustion engine, gas turbine, and fuel cell. This kind of technology, this kind of technologies and the devices have been developed. It's very important to humanity, to clean energy production. There is not clean energy. For example, hydrogen is not a clean fuel because to produce hydrogen, I need to use energy. And if I use energy, I have pollutant emissions. Okay? In energy topics, it's not right. Hydrogen is a fuel, a clean fuel. It's not good. Okay? If I use energy to produce, I have generated pollutant emissions. Okay? This is my laboratory at UNESP. It's not mine alone. There are a group of professors and the students who work about this. Okay? But these laboratories were constructed by projects, by financial support from FAPESP, the Council of Research and Development, and the CAPES, C-A-P-E-C. It's a vision of this laboratory. The Institute of Bioenergy Research in the College of Guaratinguetá, the Laboratory of Optimization of Energy Systems, and there is a partner working about the efficiency, electrical efficiency in these laboratories. We have organized some workshop also as Poly has made in this case. This energy sustainability, we have worked about this. There is some thesis about the sustainability in the hydrogen production process. It's very important. We have constructed some prototypes. In this case, I can work. This is steam reforming of ethanol to hydrogen production by the sugarcane. This is the prototype number 1, and this prototype is the number 2. There is a may reform operating about the 7 degrees Celsius, and the shift reform operating about to 300 degrees Celsius. In this case, there is a blend of ethanol, anhydrous ethanol, and the distillate water to the production of the hydrogen. Also, it's possible to use the hydrated ethanol. It's very important because the sugarcane in Brazil permits the production of the hydrogen, a small cost of production in US dollar by kilowatt hour of hydrogen. This is a mini water treatment. There are 3 anaerobic biodigesters and 1 aerobic biodigester. In this case, they use the waste of the restaurant of the college to the production of biogas in gasometer, and to control the biological and the chemical oxygen in the water, the last biodigester. This installation used the thermoplástico from Tigre, a company of Brazil. And this kind of mini water treatment is very cheap, but the life is very short because the thermoplástico has the old by 80 years. Now we have studied about the possibility of use the steel in this biodigester. Okay. This project was financed by FAPESP, by the Council of Research and Technology, and by the company, the Tigre. This is a project financed by the Council of Research and the Scientific Development. It is the prototype number 1. It's possible the gasification of biomass, eucalyptus and pinus, to production of the syngas and run the small internal combustion engine. The capacity of this engine is about 5 kilowatts. And in the case of the second prototype, we consider the input of 2 inputs of air, in this case 1 input of air. In this case the cold efficiency of the gasifier is better. It is a prototype developed by the biogas steam reforming. This project was financed by the FAPESP, Foundation of the São Paulo State. Okay, São Paulo Research Foundation in the name in English. This is the project about the production of biodiesel using waste oil of restaurants. In this case, it's very important. It's possible to produce biodiesel, but you need the treatment of this biodiesel. But after this, we have work about the glycerol steam reform. It is possible to produce hydrogen using this residual byproduct of the biodiesel production. It's very important because if you use energetic this glycerol, the cost of biodiesel production is lower. Okay? The valorization energetic of glycerol is necessary to biodiesel for biodiesel market compaction by the price of production, the cost of production. This is another project financed by FAPESP also. In this case, we use the group, my group, use the internal combustion engine of the aircraft Tucano for the training of military air force to produce using the blends of ethanol and the gasoline of the aviation. It's very important, this study. The first studies about the aircraft using ethanol. Aircraft to training of military of air force, okay? And in this case, you use the thermodynamic efficiency of the system and the medition of the pollutant emissions for the determination of the environmental efficiency of the process and or ecological efficiency. The answer of the aircraft using ethanol is different when using 10% of gasoline, okay? It's very important. These projects, ITA, Institute of Technology, Aeronautic Technology in São José dos Campos and the São Paulo State University. Is the biogas steam engine for the distributed generation using biogas. In this case, we can use the biogas from the mini waste treatment using the clean system to the filter of the some gases or some composition of biogas according to Walter Martins. Okay?
So for the previous slides, what was the blend of ethanol and gasoline?
A mixture. 5% of ethanol in gasoline, 10%, 15%.
What was the maximum?
In this case, the study was conducted considering 10% of ethanol. 100, sorry. Okay. Okay.
And do you have like the data? What was the optimum efficiency of the blend? Like when you had like, for instance, 30% ethanol and 70%.
In this PhD thesis, there is this information for you.
Okay.
This study is about the PhD thesis of Adriana Costa, all the students, and there are papers in my ResearchGate about these studies.
Okay, I'll follow you in the ResearchGate.
Okay.
Thanks.
Okay, do you have understand my English? Okay. Technical English is very important because the science is the creation of God, and you need the understanding of the science. There is a science for the development of humanity. Okay, it's very important. Many young people really in the future will be a professor, as Suani and José Roberto and José Luz. It's very important. But you need to love it. You need to love your topic. Okay? If you love your topic, you'll be a great man. Okay? Of the science. It's very important. This is adaptation of the internal combustion engine 1.0. to operate about the cogeneration systems. In this case, we can use natural gas or biogas to produce electricity, and the water of a jacket to the production of hot water. And use also the gases of escapement to produce more production of hot water. And the final use of the gases at 250 degrees Celsius to run the absorption refrigeration system to produce cold water at 7 degrees Celsius. This project also was financed by FAPESP. I love FAPESP. Okay. It's very important. Okay, thank you. I love to study these prototypes. The idea is very important in the thermodynamic studies, possibility the dimension of the heat exchangers and the thermodynamic losses.
Hi, Professor. I'm André from Rio Grande do Sul. I would like to know, I'm seeing your compact cogeneration system, and I see the absorption machine that probably there is some kind of a good lobby from Comgas to use this kind of technology. Have you ever been studying a prototype for organic Rankine cycles or developing this kind of technical solution to make compact cogeneration? For instance, you could burn in a ambient pressure boiler or something like that, and use it to make a cogeneration, a small cogeneration, without having the problems to burn it in internal combustion engines, because they have this combustion in a high pressure, and there is these problems will appear with this kind of combustion in high pressure chamber or something like that. Did you ever consider to use this kind of technology?
Organic cycles I don't have studied, but the theoretical studies I have made. But this absorption refrigeration system, the market is Robur, 50 tons of refrigeration. In this case, that I use directly the gases, I have a problem, because the original device used the burn of fuel in the device. In this case, we made the adaptation, okay? But this project, this device operating about 5 years, and after this, I don't have money to the maintenance. You understand? When we professors have a project, we have money to the project. After the project, don't have money. It's very difficult. It's not for undergraduate students. Don't use to laboratories. Do you understand? But this adaptation is very important. But there is a reduction of the life of the device. Okay? It's very important, the treatment of these gases. The exhaust gases is very important. Okay? It's all the prototypes, okay? Okay? Not operating now. Not operating now.
I would like to ask you, what solution are you using as the refrigeration fluid?
In this case, this device using the NE83 ammonia. Do you understand?
Yes.
And the water. Ammonia in this case is the work fluid. But there is another kind using bromide of lithium and water. In this case, operating the vacuum pressure, the pressure, small pressure, and the water is the work fluid. This kind of device using bromide of lithium and water is very important because the reduction of the absorption for the same capacity. For example, this absorption refrigeration, in this case, I can use in the bus to air condition it. It's a clean air condition. Do you understand? Some buses in Brazil, the ecological air conditioner, it's not true because don't use the absorption refrigeration system. But in European countries, there are some buses operating using this kind of device. It's very important.
Another question. Can you ask me why why the time you use it was shortened? Because you didn't use fuel as the heat to start the absorption machine.
In the case of the absorption machine, if you use the burning, direct burning, it's the life of the device is better, about the 15 years. But using this kind of escapement gases, the life is about 10 years in the maximum. Okay? The price of the cost of investment in this kind of device is about $250 by kilowatt of the capacity of the frigorific capacity. Okay? The last master and the PhD research thesis defended thermoeconomic analysis and ecological efficiency of a thermoelectric plant with chemical absorption of the dioxide of carbon, technical economic analysis of hydrogen production process by glycerol steam reform. There are papers in my site, okay, available. If you want it to, it's my preference, you can read. I have some students here, John and the Adrian from France, can have more information for you. This last master degree, thermodynamic, environmental and economic aspects of cogeneration with internal combustion engine operating with natural gas in comparison with syngas and biogas. It's very important. All the thermodynamic analysis, all the economic analysis, all the environmental analysis is in this thesis. Okay? Are in the technical, economic, and environmental aspects of the use the wind and solar photovoltaic in the buildings. We have a topic about the green buildings. It's very important because green buildings is the topic to the reduction of the pollutant emissions in the world. Technical, economic, and ecological analysis, the use of biogas in solid oxide fuel cell. In this moment, we have developed studies of biofuel using in all the kinds of fuel cell. Proto-exchange membrane fuel cell, molten carbonate fuel cell, phosphoric acid fuel cell, etc. Okay? Increase of the supply of electricity in the sugar and the alcohol industry, the incorporation of combined cycle associated with the fluid bed gasifier, it's very important. We have my group, okay, has work about also the paper and pulp industry, considering the combined cycle. Because in Brazil, the traditional process use the craft process. In this case, there is only the use of the steam turbine, condensing steam turbine, and we can use the combined cycle in the pulp and paper industry also. There is in this moment a PhD thesis in development by Christian Lau, my students, by the program of bioenergy of São Paulo State University, University of Campinas, University of São Paulo. about the potential of the bioelectricity production using combined cycle and gasification in the pulp and paper industry. Okay? I love this topic, sorry. I love this. Suoni, Professor Roberto also, I believe. I love it. It's my life. Okay? The presentation of the book, this book in Portuguese, Bioenergia. This book was written by Professor at UNESP, professors of the Institute of Bioenergy Research. I have 3 chapters in Portuguese: the use of biogas to production of cold water and the electricity, biodiesel and syngas in internal combustion engine, use of ethanol for production of hydrogen and for use in aircraft engine. In this moment, we have a project financed by the CAPES and the Scientific and Technology Foundation of Portugal. It's very important. In this project, we have considered the use of syngas blend this mixture to biodiesel, to the bioelectricity production, using gasification of the urban waste, solid urban waste, and the biogas from the urban organic waste. This is the chapter of the book, Biofuel in Brazil. In this chapter, technological advancements in biohydrogen production and bagasse gasification process in the sugarcane industry with regard to the Brazilian conditions. This book in English is available in the internet. Okay, you can read this book. In my ResearchGate also the chapter is available. It's the last publication in 2017, Sustainable Hydrogen Production Process, Springer, a good publishing. This book is available also in my ResearchGate, and it's possible read this book by Springer. It's available to read. But in my ResearchGate, available to, okay? It's very important. If you like work about the hydrogen, this book is a basic for your studies. Professor José Roberto was told about this, and it's a good reference to your study, okay? The development of science, I consider the papers, books, need to be available. It's not important for the full professor to publish it, and don't show for the peoples. The peoples need show and read and study. Okay, it's very important. This is a project from the CNPq about the gasification of sugarcane bagasse. In this case, it is the prototype to the fluidodynamic studies, because there is sandy and the particulate of bagasse, small particulate, and the air entering make the flux current. And it's possible the mechanical fluid applied in this gasification. For the development of the gasifier, this study is very important. The sphericity of the biomass, the granulometry of the biomass is very important. Okay, então, so start with mechanical fluids, fluid mechanical studies, and after this to thermodynamic studies. I think the thermodynamic is the biggest topic of universe, the creation of universe, I consider the thermodynamic issues. I need to use mathematical models, I need to use fluidodynamic, I need to use heat transfer to complete the thermodynamic studies. It's very important. Many people don't like thermodynamic, but thermodynamic is not the difficulty. Thermodynamic is the best topic of word. I love it, okay? This is the development of the gasifier after the second step. In this case, my students is about a test. There is a thesis about this. Use of the work solid to design of the gasifiers. After this, we have this, the construction of the gasifier. This project was also financed by the Council of Research and Development of Brazil. Okay, it's very important. Now I have the prototype, but I don't have money to the operation. Okay, it's very important. I don't have money to operation. I need to make another project to financial support. It's not good for the resources.
Thank you. Just a quick question. Can you shortly explain us how it works, so which unit is what?
Okay. In this case, there is the entry of biomass, prepared biomass, sugarcane bagasse, in this point. And in this point, there is input of air by separator. Okay? And there is inert material sent, and the bagasse in this point. And there is a later fluid Z bed as a fuel, and there is the region of pyrolysis, and after this, the gasification. There is a cyclone to material particulate separated. There is a heat exchange to separate of tar. After this, I have a syngas for using micro gas turbine, okay, in heat recovery steam generator, in heat steam generator. I can use this kind of thing. The gasification is very important. When I have syngas, depending of the gasification agent, I can use air, I can use the oxygen pure, I can use steam as a gasification agent.
Okay. Thank you. And one more question. Is there something unique or specific about this prototype of gasification different from other plants?
In this case, a small gasification, but there is not some experimental studies about the gasification of sugarcane bagasse. Okay. Do you understand? There is using another biomass, another kind of fuel, but not sugarcane. And my proposal, the proposal of my group is this increase of the bioelectricity production in Brazil using biomass in the pulp and paper industry and sugar cane industry. There is a supply of electricity in the sugar cane industry, but there is not supply of electricity in the pulp and paper industry. Do you understand? And you need the increase of the electricity production, the bioelectricity production. In this moment, there is a crisis. The water in the reservoirs of the hydroelectric, it's not good in this moment. São Paulo, perhaps there is a crisis. There will be a crisis about this. Okay, and we have work about the potential. Pulp and paper and the sugarcane industry is the most intensive factors using biomass, energy from biomass. And you need to increase this. And this kind of technology is very important. In the next is a new project. These projects have been financed by the Council of Research and Development. I love saying PQ. Okay, very important for us for the development. In this case, we have photovoltaic systems in my laboratory, and we have bought a wind turbine, vertical wind turbine. In this place, Guaratinguetá, there is no velocity of wind adequate as in Fortaleza, for example. So horizontal wind turbine is not possible because the horizontal wind turbine needs in the minimum 4 meters by second of the velocity. In Guaratinguetá, there is a velocity of about 2 meters by second. In this case, vertical turbine is recommended. Okay? It's very important. Biogas using in internal combustion engine to electricity production. In this case, I have a smart grid solution to some homes, some houses. And in the case of supply, I can use it to electrolyze it to production of hydrogen by electrolysis. In this case, solar hydrogen. In this case, wind energy hydrogen. In this case, biohydrogen, because I have using biogas to bioelectricity production, and after this, biohydrogen production. It's very important. And we have studied and the smart grid about the cars, because in the future, the electrical car need use fuel cell also, because the autonomy, because the kilometers is very important. Electrical car is limited today about 100 kilometers. But if I have storage of hydrogen and fuel cell, 400 kilometers. Okay? It's very important. Future, the electrical car. Fuel cell car is electrical car, but different because there is a storage of hydrogen. Okay? Not only batteries. Okay? Então, it's very important. Many theses and master degree studies in this case. Okay?
Thank you. I have a question regarding this system in general. So, for example, you burn biogas to produce electricity, and then you produce hydrogen from this electricity, and then part of this hydrogen will be used again to produce electricity for residential
when
sector.
When I need. Okay, sometimes you have many bioelectricity, but not needed to the consumption, the requirements. And you need a supply of electricity, and used to hydrogen production.
Yeah.
Okay? Storage of hydrogen is the manner of storage of the electricity.
But isn't it more efficient to store biogas directly instead of storing the hydrogen?
See, there is the electrolyzer efficiency is about the 60%, but the solar energy is about the 15%. The final efficiency to hydrogen production is the multiplication of the efficiency of this power plant to efficiency of this electrolyzer. See, it's very important. And the hydrogen will be produced when I have supply of electricity only. In Germany, there is some power plants operating based in this model. Okay? We have papers about this, and you need to consult this to the profundation. I have a student working about the hydrogen production by glycerol, João Tavares, and I have a students from France, Institut La Rochelle, Adrian, working about the electrical vehicle electrical car. Okay, it's very important. The future. But it's very important to the reduction of the pollutant emissions. These projects now, okay.
I say, please, can you go back to the
Okay.
slide? Yeah, it looks like a hybrid system, right?
Yeah,
Yeah.
the
So,
name is hybrid
hybrid
systems,
system, yeah.
considering electricity, but bioelectricity, but hydrogen production also.
All right. I want to know the methodology behind. Is it like, did you use mathematical modeling or stimulation to?
Yes, yes. There are 2 or 3 theses about this.
All right.
I recommend for you the PhD thesis of Justo Roberts.
Okay.
Justo Roberts is an old student, master, PhD, and postdoctorate student from National University of Mar del Plata. And they work together, my friend, the Professor Agnello, together José Luz and Professor Celso Tuna also. There are, in my research gate, papers, a new paper about robust optimization of hybrid systems. Okay? You can read it, download it. I have information. Okay?
Thank you very much.
I believe that the students need to make a work in this course. It's okay? Yeah? Please consult these papers.
Yeah, actually, me myself, I'm into hybrid systems.
Yeah.
And I always want to learn new things about it. Like, if there are other ways to, size an hybrid system. I know how to use OMA. Actually, I'm using OMA for my master thesis.
Oh, okay.
So I wanted to know if, like, he also used another method, maybe a mathematical modeling.
Modeling.
There is also a algorithm. So I just wanted to know, so that maybe I can go and read about it and also have a fair idea.
I recommend a new publication this year about the hybrid systems to electrical car in Ilhabela city. Okay. Also, there is a paper about the hybrid systems using to Galapagos Island. New publications. In this year, we have in my group about 5, 6 paper. A1, high impact factor. In English, you don't speak Portuguese?
No. Okay. Thank you very much.
Okay. This project is very important. We have in my laboratory, Institute of Bioenergy Research at Guaratinguetá, in Guaratinguetá, the title of Institute of Innovation, Scientific Innovation and Technology. This project was approved, but the deliberation of the research is not still, okay? But we have work about the many topics using the energy conversion of biomass. It's very important. The coordination of this project is by my friend, Professor Electo Lora, from Itajubá City, at the Federal University of Itajubá. Electo Lora is a good resource. Professor at Unesp, vice coordination as I am the vice coordination. CTBE in Campinas, University of Santa Maria, University of Campinas, professor of University of São Paulo. It's very important. Many researchers, many full professors work together using your students and my students to develop some research. We have also the production of process and use of innovative hydrogen, technical economic approved. Also, in the finalization, the international exchange student, the project entitled 100,000 students from National Foundation of the America, of the United States, of And in this case, the Wisconsin University of Prattville has worked together as. It's very important. I received the visit of the 5 students from this university and the 1 professor. And in my laboratory was organized a congress, an international workshop. And these students made a lecture about your studies. And my students in University of Wisconsin-Prattville also made a lecture about your researches. It's very, very important. Green building solutions to reduction of the greenhouse gases. This project I told, the use of blends of biodiesel and syngas internal combustion. The idea in this project is the valorization, energetic valorization of the waste, organic waste, and the not only organic, okay, the paper, organic, also the waste to the gasification. For example, the oil in the city, we can use the oil in the city to the biodiesel production. Okay? It's very important. In these studies, in Guaratinguetá, the peoples of the College of Engineers of Guaratinguetá have considered the Guaratinguetá city because I have information about the residues, the municipal residues. Okay? Well, the first part. Now, technical, economic, and environmental aspects of hydrogen production process. There is a thesis, PhD thesis, of doutora, today Dr. Lúcia Bolini Braga. Okay, Lúcia Bolini Braga is a tenant from the Air Force in Brazil, and you work about this process. The chapters of your thesis is about the introduction, the state of the art of hydrogen production process is in Portuguese, okay? But there is a book of Springer, some chapters use this thesis, okay? There is studies about the production of hydrogen by steam reform, production of hydrogen by electrolysis, the production of hydrogen from algae. There is thermodynamic analysis of the hydrogen production process. There is analysis of hydrogen production process, and environmental analysis of hydrogen production process. In the case of environmental analysis of the energetic process, there is 6 models of the environmental analysis. But in special, I like a model of Cardew and Barker that consider the emissions of pollutants indicate for the organization of World Organization of Health. There is limits of the emissions for human life, for vegetal life, okay? And you consider this to the determination of this environmental efficiency. This thesis is written in Portuguese, but there is 5-6 papers published in journal in English about this. Okay, in my site is available these papers. Okay, some students are hydrogen. I need. There are many papers, okay, but we have it also, okay. The objective of this PhD thesis is access to hydrogen production process, technical, economic, and environmental issues, technical energy efficiency of each process, economic determination of the cost of hydrogen production based in US dollar by kilowatt hour. You know the hydrogen has a high lower heat value, high energetic density. The lower heat value of the hydrogen is about 120,000 kilojoule by kilogrammeter. In comparison, the natural gas is about the 47,000 kilojoule by kilogrammeter. Why to produce hydrogen? Because hydrogen is a small molecule, it's a fuel with high energetic density. Okay? It's very important. The humanity needed to storage energy, and the hydrogen is possible to storage hydrogen. Some pictures about hydrogen production process analyzed, thermochemical, electrolyte, photolytical, okay? Steam reform for hydrogen production. In this case, fuel and water, steam generator to produce the steam of the mixture, in the main reforming process to operate about the 700 degrees Celsius, and you needed a shift reaction to the reduction of the monoxide of carbon, because monoxide of carbon it's not good to the, for example, proto-exchange membrane fuel cell. The contamination of the electrolyte, it's very bad to the life of this kind of the device fuel cell. Porque the production of hydrogen is to use in fuel cell. Okay? It's not possible the direct combustion, internal combustion engine of hydrogen, because the temperature is very, the material, okay? In this case, the internal combustion engine need to be construction using niobio, zirconium. It's very, very expensive, okay? Many people think, why you don't use direct hydrogen internal combustion engine? It's not possible. You can perhaps use a small quantity of hydrogen. Some experiments, some studies consider the car use internal combustion engine with a small electrolyzer to hydrogen production and the injection together the gasoline. Okay, it's possible. But our hydrogen, it's not possible. Okay, it's very important. In this case, to steam reform, the prototype number 1, the biogas steam reform. There is a small steam generator. Steam generator is produced and input in the reform together biogas to the chemical reactions to production of hydrogen. Electrolysis process, you know, in the undergraduate studies, imagine studies, the electrolyzing, anode, cathode, the electrical current in water, distillate, hydrogen, oxygen, okay? The fuel cell is a reverse process. Hydrogen in anode, oxygen or air in cathodes to production of electricity, okay? This is a wind energy process. You produce electricity to the building, using the electricity to electrolyze, to produce the production of hydrogen. It's very important process. Sometimes the wind, the velocity of wind, the production of the electricity is, there is a supply of electricity. Solar hydrogen production. This device, this scheme is shown in the book of Springer, okay? Sometimes when I has water, in the night in the hydroelectric power plants, I can use the production of electricity to using electrolyzer to production of hydrogen, and I can storage hydrogen to use in another time. microalgae and the algae, use the microalgae. There is a process also using cyanobacterial. The cyanobacterial eat the microalgae and make the production of hydrogen, the pool hydrogen. Okay, this is the process. Okay, the solar lighting or the lighting the night lamps, special lamps to permit the production of hydrogen. This is a research developed together Florida State University. My friend, Professor Juan Ordones, was a co-supervisor of these theses, and the experimental studies was made in this university. Some characteristics. In this case, we have the average of Gibbs free energy after the 200-300 degrees Celsius. There is the production of hydrogen. There is the constant equilibrium about the production of hydrogen. Many kinds of steam reform process, steam reform of methanol, indicated about up to 450 degrees Celsius. There is the production of hydrogen. In the case of ethanol, this is the curve. In the case of natural gas, is the curve indicating the minimal temperature to production of hydrogen. There is the determination of equilibrium constants for the calculations. Many cases, in this case, is about the biogas steam reform in comparison with methanol and natural gas. Many kinds. Reactor shift. Sorry, some curves. The influence of the pressure. Many times people consider high pressures to steam reformers. It's not necessary. More pressure indicated more level of irreversibility in the process. Okay? Because high pressures, I need more energy to operate. Okay? It's not so good. Many cases, I don't have time, and I need this power plant energy efficiency of electrolysis process. It's very important. Electrolysis to wind hydrogen production. There is 29–30% of the efficiency, global efficiency. Solar about the 10%, 12%, 11%, because the panel photovoltaic has a lower efficiency of power plant. Electrolysis for hydroelectric power plants is very high because the efficiency of the hydroelectric power plant is very high, 90%, 80%. You understand? It's very important. Efficiency of algae, microalgae production of hydrogen. A comparison with the energy efficiency of the process. Steam reform of biogas, steam reform of natural gas, steam reform of ethanol, very good. In this case, not considering the credit of the oxide of carbon. There is a credit because the photosynthesis, okay? So it's very important. Electrolysis from wind energy. Electrolysis from photovoltaic systems. Electrolysis from hydroelectric power plants. Biophotolysis with the algae, microalgae. The comparison about the level of efficiency of the hydrogen production. And some equations to economic analysis. in this process, the cost of hydrogen production in US dollar by kilowatt hour of hydrogen depends of the investment in the process, depends of the operational costs, it depends of the maintenance cost. There is all the information in this book, in this thesis for you. The determination, these figures, in this figure is shown the hydrogen production cost as a function of the payback period, considering the number of utilization, operation hours by year. You have higher hour of operation, minimal cost of hydrogen production. In this case, natural gas steam reform, the cost of hydrogen production. In this case, biogas steam reform. In this case, wind power, wind hydrogen production cost. In this case, hydrogen production cost considering the solar energy, very expensive. In this case, hydrogen production process in hydroelectric power plants. Using algae, and the cost, hydrogen production cost in the all process. Steam reform of ethanol is very good. It's very good. It's very cheap. I believe in the hydrogen production in the sugarcane industry in the future. Okay? The power plants, the sugarcane industry can sell also hydrogen in the future. It's very important. About the environmental efficiency, the modeling of Cardu and Barca, and this equation which indicator of pollutant emissions, equivalent dioxide of carbon is determined by all the process, and I have in the final a comparison with all the process, environmental efficiency, dioxide of carbon equivalent indicator, pollutant indicator, kilogrammeter of the dioxide of carbon equivalent by kilogrammeter of hydrogen, and you has the indicator, the best efficiency is algae. Environmental efficiency is very high. And the lower efficiency is for this process, steam reform of ethanol in this case, but do not consider the credit of dioxide of carbon, okay? If I consider the dioxide of carbon, the second inhalation algae. And it's not important, I don't have time, but it is very important. Okay? It is very important. The future, the landfill of the communities, of the cities, will be producing bioelectricity and also biohydrogen. Okay? It's a work of Gabriel Bricio Nóbrega. In this moment, Gabriel is studying in the Grenoble University, working together Professor Agnello, José Luz, and Regina. He studied technical and environmental issues of hydrogen production process from biogas and its use in PEM fuel cell, proto-exchanging membrane fuel cell. In the past, naphthalene was a waste, naphthalene from DuPont. And after this discovery about the electrochemical properties of this material, and now this material is very expensive, okay? Because this kind of PEM fuel cell is very good to electrical car, operating about 100 degrees Celsius, okay? What is hydrogen? Small molecule, not clean fuel, because hydrogen is It's not in the nature. I need energy to hydrogen separation of oxide, of acid. Okay? I need energy for separation of hydrogen of water, electrolysis process. I need electricity. So there is pollutant emissions to hydrogen production, for hydrogen production. It's very important. When you listen, the hydrogen is a fuel, a clean fuel, not clean fuel. There is not hydrogen free in the nature. Okay? Many scientists talk. Hydrogen is a fuel, a clean fuel. It's not clean fuel. Okay? What is fuel cell? The fuel cell, what is biogas? Huh? The biogas is a fuel that contains methanol, CH4, and the dioxide of carbon. Huh? Types of hydrogen process. In this case, you also consider use of biogas. Two cases: electrolysis, using bioelectricity from biogas of internal combustion engine, and the steam reform of biogas. Okay? Technical analysis, thermodynamic studies, environmental analysis, consider the use of hydrogen in fuel cell to electricity generation, and some discussions. So, hydrogen, simplest elemento. Hydrogen is a small molecule. It's very difficult to storage hydrogen. For example, the tank of storage of natural gas, it's not possible to use it to hydrogen because the hydrogen enter in the pores of the tank. There are another kinds of material to hydrogen production. The hydrogen, it's very important. For example, water energy to production. There is not a fuel clean in the case of hydrogen. We consider some studies to reduce environmental greenhouse gases. In landfill, there is the production of biogas. This biogas I can use to produce hydrogen. Fuel cell, there is the anode, cathode, the electrochemical substance to production of electricity. In this case, it's a part of the old projects that you have developed. In this case, use biogas, steam reform, direct to hydrogen production, or use the biogas to bioelectricity production, and use of this bioelectricity to hydrogen production. And this hydrogen is considered in fuel cell. It's an electrolyzer, commercial, available in the market, electrolyzer, steam reform of the biogas, some electrolyzers in the market, the capacity of hydrogen production, the power consumption, and there is some equations. The electrolyzer efficiency to hydrogen production is the region in the hydrogen energy production, power production, by the consumption of energy in the process. See? There is a thermodynamic efficiency of the process, the electrolyzer efficiency, and the efficiency of the engine. Energy efficiency, the flux of biogas, it's possible to use this equation to determination of this energy parcel. Some equations. Biogas, for steam reforming of biogas, The efficiency of the steam generator is considered. The thermodynamic efficiency of the biogas is reform process is the max flow of hydrogen, low heat value of hydrogen, the energy using in process, biogas and low heat value, and the biogas to steam reform. In this case, you use the biogas to bioelectric production and the biogas to conversion to hydrogen. Main equations, it's the dioxide of carbon equivalent. This paper is available also in the site, in my site. The pollutant indicator, the environmental efficiency using the model of Cardu and Barca. Electrical car in the features use also fuel cell, proton exchange membrane fuel cell, and many equations to calculation, many informations, and some results of the biogas composition, low heat value of the biogas, and the results thermodynamic efficiency of the process, steam reform of biogas, and the electrolysis of water. Electro water present a small efficiency, but it's very important. The steam process, the steam reform, many times is very expensive to consider. Some equations. The conclusion, the use of biogas from landfill of São Paulo city for bioelectricity generation. It's very important. It's a part of the master degree of Mariana Carvalho Guimarães. These theses in the middle of the development. Regina Francielli is a PhD student and he studied about the use of biogas to bioelectricity production also. Objective is to the development of technical and economic analysis of the use of biogas generated in landfill from São Paulo City, Brazil. Make a comparison of the use of internal combustion engine or micro gas turbines. Thermodynamically, there is a difference to use your micro gas turbine or internal combustion engine. Why? Internal microgas turbine has a ratio air to fuel about the 60. In the other hand, internal combustion engine has a ratio air fuel about 11. Okay? 10. So in microgas turbine, there is more quantity of escapement exhaust gases. So I can use the technology of cogeneration also. But in Brazil, there is not some application because in Brazil, the climate is about 25 degrees Celsius. And there is no, but in Europe, in landfill of European countries is very important to cogeneration consideration. The landfill use the organic waste of the city. In landfill, there is the production of biogas. There is the production of the waste oil, named the slurry, okay? And the recirculation of this residual waste is very important to increase the biogas production. In landfill, there is a life, has a cycle life, 18 years to production of biogas. After this, the biogas is decreased the production. The useful life of the landfill is about 30 years. Okay? 30 years.
Professor, may I have a question here?
Okay.
Okay. Are you assessing the feasibility to use gas turbines or internal combustion engines? It's as far as I know, it's more cheap to buy an internal combustion engine here in Brazil to use in this kind of for this kind of solution. But there is an assessment. How is the concentration of methane in your biogas, which is the kind of assessment of the pollutant emissions from one kind of combustion to another. Both are in high pressure ratios. You know, they generate some kind of pollutants that again doesn't happen when you are burning this in ambient pressure. And did you see as a feasible solution use this kind of gas turbines or with bottom cycles that could generate also energy as I already said, organic Rankine cycle, or there is this one with ammonia that you mix up with water, which are a kind of Rankine cycle that is already used extensively in Europe, but in Brazil, in South America in general, there is only one installation in Chile, which are an installation that will made something around 15 megawatts. See, this is a kind of technology that's feasible to generate a lot of electricity, but why I do not see any kind of movement to study it?
I believe in organic cycles, use the cycles in landfill. I believe in the future. I know some papers about this, but in Brazil, in this study, we have considered the micro gas turbine because some landfill in São Paulo city already use the internal combustion engine. Yeah. And in this case, the power capacity of the internal combustion engine is not a higher capacity, because in the market there is not many internal combustion engine with the high capacity available.
Yeah, for sure. I see.
But in organic cycle, I believe in the future to use in the landfill.
We do have this landfill which is called Minas do Leão, back there in Rio Grande do Sul. They already have 7 Embarker internal combustion engine, each one of something around 800 kilowatts. They are still operating. They will double the size of this generation plant. They are trying to reach something around 14 megawatts. But when I visit there, they have 7 internal combustion engine and another one to use to spare parts, because this is a really aggressive kind of combustion to use in. Did you make some assessment? You may be not able to talk right now, but I can found in your paper something that I can find what kind of pollutant, what kind of corrosive or something.
Yes. That it's very important to the future of the biogas to use internal combustion engine as internal in micro gas turbine. I understand that the biogas, the composition of biogas of landfill is very good. It's about 60% of methane, and the 40% about the dioxide of carbon is considered in this case. Okay, but I have some information for you about your question. Okay, is the evolution of the waste, municipal solid waste in the Brazil. Okay, it's very important. The increase. It's the municipal solid waste generation has increased. In São Paulo city, visiting São Paulo today, I see the river, and it's very important. The population need to be educated about this. It's not a political problem. alone, the population is responsible to the generation of this kind of waste, okay? And the landfill, modern landfill, and the biogas production, the recirculation, it's very important. Landfill has a lifetime about 30 years, and 18 years to produce, increase the electricity production, and after this, decrease. So the economic analysis is very important because this decrease the high cost of production, of bioelectricity production, biogas production. We have considered the purification of gas, okay? Landfill, the biogas, use internal combustion engine or micro gas turbine. The idea is a comparison about the bioelectricity production. So the biogas composition, considered in this study, the Caeiras landfill, the production of biogas, the CDR landfill of São Paulo, and the CTL. Based in this quantity of biogas available, what is this capacity of the bioelectricity production? I don't have time. Tá bom. Isso, rapidinho. Electrical efficiency of the micro gas turbines, electrical efficiency of the internal combustion engine used considered in this study. There is some equations about the economic analysis, investment parcel, operational composition of the electricity cost, maintenance cost, the investment in internal combustion engine, the investment in gas turbines, the annuity factor. The annuity factor depends on the payback period of investment and the annual interest rates. It's very important. And the annual expected saving. The annual expected saving of the landfill. When the landfill company gain producing bioelectricity, it's very important. And in this case, internal combustion engine, the total electricity production, biogas production, Caeiras, quantidade de internal combustion engine e também quantidade de turbinas a gás was studied, and the capacity of bioelectricity production using internal combustion engine, same the capacity using gas turbine, because the thermodynamic efficiency is similar in this case, depending of the kind of the micro gas turbine studied, okay? And in this case, the total of toneladas by day, tons by day of the municipal residents, the quantity of biogas, and the quantity of bioelectricity production capacity. It's very important. This kind of production, this capacity is the capacity more or less more or less of Guaratinguetá city. Guaratinguetá city need this capacity. There is these requirements of electricity in the city. São Paulo city is a big city, and some results of the economic analysis, the gain, the payments, the payback periods to internal combustion engine, and to micro gas turbine. Micro gas turbine is very expensive, the cost of electricity production. And the conclusion, I wanted to introduce this thesis, this master degree thesis. This thesis is written in English, okay? There is a paper now, publishing now in the International Journal of Exergy Analysis, okay? This thesis I recommend for you, Thermodynamic, Economic, and Emissions Analysis of a Microgas Turbine Cogeneration System operating on biofuels, syngas, and biogas, and natural gas. Benjamin Kant is a student from Germany. This thesis is right in English. I don't have time, professor, sorry if by time you use it. Thanks a lot for your attention. If you have some question, please let me know, okay?
Okay, my name is Daniel. I'm from Brasilia. My question is regarding to the internal combustion engine. You know, when you use biogas in an internal combustion engine, you need to make some arrangements in the water cleaning system. But I don't know what are these arrangements. Do you know?
It's not the same efficiency. It's not considered the same efficiency. There is another master degree thesis about the use of biofuel in internal combustion engine. There is an equation to the correction of the efficiency. Use thermodynamic efficiency using natural gas, using syngas, and using biogas. I can show for you. In this case, I go directly to this equation because I don't have time. Professor Sony is...
Professor.
But I have this equation for you. There is a correction of the capacity, the thermodynamic efficiency of the process. In this equation, you can...
Professor.
Why?
So, in my question, I was asking what modifications do you have to do in the
mechanical modification?
Yes, in the water.
There is no.
No, the water cleaning system has problems with this.
The thermodynamic efficiency of the internal combustion engine?
No, not about the efficiency. It's about it working without breaking.
Working, the time to work.
The water cleaning system. If you use biogas in an internal combustion engine.
Yes, you need to consider the investment in the clean systems, in the filters of biogas. Because natural gas is a clean fuel. There is not a sulfur in the natural gas. But sometimes in the case of the biogas, perhaps there is. Yes. So the composition of the biogas in the landfill don't consider sulfur. But in the case of the syngas, in the case of biogas, more methane, and after the dioxide of carbon. In the case of syngas, there is more the composition of hydrogen, and the second dioxide of carbon, and the methane also. So in stoichiometry, in the calculations, is modified. In all these cases, not consider the sulfur, because the composition, there is not sulfur in this case.
Okay, thank you.
Okay? I want to invite you to visit our site, and also, as Suani, Professor José Roberto, invite you to try study in São Paulo State University, okay? We have worked a lot about bioenergy, renewable energy, and we have also, as my colleagues from Campinas State University, University of São Paulo, sister University of São Paulo, at São Paulo, working a lot about this topic, okay? I want to invite you to visit our laboratories and to participate also some the workshop and congresses that we have organized as the Latin American Congress on electricity generation transmission. The next Congress will be in Santiago in November 2019. And I want to invite you in November in Santiago, Chile. Okay? It's very good. Student pay ship. Okay? Okay. Thanks a lot for your attention.
Thank you. Okay, so we are closing our bioenergy sections.